Okay, chemistry. This is a brief introduction to measurements that we'll do in the lab using some of the equipment that we will be using in the lab, and how you read the equipment. What's the proper number of digits that you read your measurement? Okay, so distance. So a ruler below shows metric units on the top, those are centimeters, and imperial or English units on the bottom, those are inches. In chemistry, we do all measurements in metric units. The number units on the top are centimeters. The small lines in between each centimeters are millimeters. So there are 100 centimeters and 1,000 millimeters in a meter. Now let's take some specific examples. You see the arrow pointing to the 4, so the measure is exactly on the 4 centimeter line. That's what you're estimating your measurement as being. Millimeters represent 0.1 centimeters. So if the arrow were to the right or left, it was slightly to the right, it would be 4.1 centimeters. If it was slightly to the left, it would be 3.9 centimeters. In addition, the measurer is allowed to estimate one more decimal place. This allows the measurement to be 2 places after the decimal. So let's say it was just after the 4, but not quite to the 4.1, not quite to that first little millimeter line. Then you could say it's 4.05, for example. You can estimate how far is it between the 4 line and that first little line after, which would be 4.1. So you're allowed to do that, and you're not only allowed to do that, you're required to do that. So this measurement should be 2 places after the decimal. Okay, let's look at this. We have the arrow pointing exactly at 6.7. So the measure is exactly 7 millimeters after the 6 centimeter line, but you're still required to make that estimate digit. So if you think it's exactly on the 6.7 line, then you should say 6.70. Over here we have 10.25. So you look at that and you say, okay, it's past the 10. It's 2 lines past the 10, but it's actually a little more than 2 lines, but not all the way to 3 lines past the 10. So you would say that's somewhere in between 0.2 and 0.3, so that would be 10.25. Again, in all 3 cases here, you're going to 2 digits after the decimal point on a ruler like this. One more. Okay, this one you look at it and you say, okay, it's 12 and it's 1, 2, 3 lines, but it's almost to the 4th line, but not quite to the 4th line. So that's your guess digit. So you would say it's 12.3, and if it's almost to the 4, you could say 8. You could say 7, you could say 9. Again, that's your estimate digit, but in this case, we're going to say it's 8. Liquids form what appears as a disc on the top. That disc is really more of a bowl shape. What happens is, because of the properties of water and the properties of glass, the water kind of climbs up the sides of the glass, and so it forms kind of a bowl climbing up around the sides. The disc is called a meniscus. The height of the liquid is measured from the bottom of the meniscus, where that arrow is pointing. So each of the numbered lines is a milliliter. 21 is a milliliter, 22 is a milliliter. The small lines represent 1/10 of a milliliter. So think about it. Stop the video, and how would you read that measurement? Well, it's increasing as you go down. So as you go down, it's going from 21 to 22. And it looks like it's going down about 3 smaller lines below 21. So that would be 21.3. But remember, you need one more estimate digit beyond the precision that you can actually see on the lines. And to me, the bottom of that meniscus looks like it's just a little bit below that 3rd line. You may not think so, but I think it's a little below that 3rd line. So I would read that as 21.31. A triple beam balance is used to measure mass. The illustration below shows the beams on a triple beam balance. The center beam is in increments of 100 grams. It's put in the center so the balance won't tip over the heaviest one. The top beam is in increments of 10 grams, and the bottom beam is in increments of grams. Now, so you have 0 through 10 grams on the bottom beam, plus you have increments of 1/10 of a gram. Those are the smallest lines that you see. So the reading on this scale, think about what you would say this reading is. Okay, so the reading would be 536.80. Okay, so let's look at it. You see the biggest weight is on 500. The one on top is on 30, that's 530. And then if you go down to the bottom, it's past 6, but it's not all the way to 7. So it's 536 definitely, and now you have a decimal point, and it looks like it's right on the 8. The 8th little line past 6. But maybe you think it's a little after or a little before the 8, so you need that additional guess digit, estimate digit. I think it's right on the 8, so it's 536.80. The 0 is the estimate digit. The resolution of the image is not clear enough to tell where that point lies between 8 and 9. Time is measured in the same units in any system: seconds, minutes, hours. Also calendar time, days, weeks, months, and years. And centuries. All right, so that takes care of a brief introduction to how you read instrument measurements, and we'll do get a lot of practical experience with that in the lab.